Here's sample test 3, problem number 8. An electron has a velocity of 6 times 10 to the 6 meters per second in the positive x direction at a point where the magnetic field has the components b sub x equal to 3 Tesla, b sub y equal to 1.5 Tesla, and b sub z equal to 2 Tesla. What is the magnitude of the acceleration of the electron at this point? Well, we know for a charge on an electron, that's equal to negative e, which would be a negative 1.6 times 10 to the minus 19 coulombs. Just the negative of the charge on a proton. The velocity in this case is 6 times 10 to the 6, strictly in the x direction, meters per second. And the magnetic field as a vector would be equal to 3I plus 1.5J plus 2K Tesla. So there's our three main things that go into our force formula. Our force is going to be equal to Q V cross B. So this is equal to a negative 1.6 times 10 to the minus 19 coulombs for our Q. And then for our V, we have 6 times 10 to the 6I crossed with our B, which is 3I plus 1.5J plus 2K. Well, since the 6 times 10 to the 6 is being crossed through all those components, it's going to be a factor in all those components. So I'm going to just multiply that out with the charge. And so the negative 1.6 times 10 to the minus 19 times 6 times 10 to the 6 is going to give me a negative 9.6 times 10 to the minus 13. And then what I'm left with is a I crossed with 3I plus I crossed with 1.5J plus I crossed with 2K. Any vector crossed with itself is going to be 0. And if we look at our mnemonic device, where IJK plus negative. If we have I crossed with J, we're going to end up with positive K. And if we have I crossed with K, we're going to end up with negative J. So, our force is looking like this. Negative 9.6 times 10 to the minus 13. And then we have I cross 1.5J is going to be a 1.5K. And then I cross with K is going to be a negative J, so that's going to be negative 2J. And that is our vector force responsible for this from this cross product. We want to find the magnitude of that force. So the magnitude of this force, which I could just call F, would be equal to negative 9.6 times 10 to the minus 13 times 1.5 squared plus negative 2 squared, all that, square root to the 1/2 power. So this is going to be negative 9.6 times 10 to the minus 13 times 2.5, which is a negative 2.25, yeah, 2.5, which is going to be negative 2.4 times 10 to the minus 12 newtons. And we just want the magnitude of it, which Should put the magnitude on this. So the magnitude is 2.4 times 10 to the minus 12 newtons. That's the magnitude of our force. Nice to know, but we want the acceleration. And if this force is the only force responsible for the acceleration, then by Newton's second law, mass times acceleration is equal to our net force, and acceleration would then be equal to the force divided by the mass. So that would be 2.4 times 10 to the minus 12 newtons divided by the mass of an electron, 9.11 times 10 to the minus 31 kilograms. Hope you have that memorized. So this is equal to 2.63 times 10 to the 18 meters per second. So that is the acceleration of the electron, 2.63 times 10 to the 18 meters per second squared. I was just kidding about you memorizing the mass of an electron. If I asked you this question on a test, I would give you the mass of an electron.